In today's video, let's talk about the concept of agent. So first we have to talk about memories. So they have two forms of memories, which is first the long-term memory, which is the pre-trained knowledge, and the second is working memory, which is the contextual reasoning and temporary information holding. They working together to create a powerful language agent, which is capable of general purpose reasoning. So the agent uses long-term memory for instant recall of facts, and it also have the working memory to process and adapt to new information in real time. So this combination allows this agent to handle the wide variety of language-driven tasks. This is much like a human, right? Can switch between remembering learned facts and thinking through a current problem also. Let me give you an example about combining long-term and working memory. Suppose you are writing a report on climate change and you ask an agent, what are the main causes of global warming? The agent pulls from its long-term memory. Well, it has stored knowledge from the pre-trained about environmental science by giving you a general answer. The main causes of global warming are the increase in greenhouse gases like carbon dioxide, methane, and nitrous oxide, primarily due to human activities such as burning fossil fuels and deforestation. And then you might ask it to reason over this knowledge with new context. Can you help me to summarize this information in less than 100 words for a non-expert audience? So now this agent uses its working memory to hold the original information to rephrase it to suit your new request. In this case, the agent's long-term memory provides fundamental knowledge, while the working memory allows it to adapt to the current task, which is to do summarization, which is showing the flexibility in how it uses the stored information. So for large language-driven reasoning, by combining these two types of memory, this agent becomes highly versatile and capable of handling these general-purpose reasoning tasks. And then, let's talk about long-term memory, which is the pre-trained parameters of the large language model. For example, imagine if you ask the agent who wrote Moby Dick without needing to think or perform any real-time reasoning, the agent can instantly answer Herman Melville. This is because during the pre-training, the agent has encoded this fact into its long-term memory, as if the agent has already read a lot of literature and stored the key information like the author's name and book titles in its memory. The long-term memory of a language agent is mainly the pre-trained parameters of the large language model. So this refers to the vast amounts of knowledge and linguistic information that the model has learned during its training on the large data sets. For example, think of the large language model as have learned from reading millions of books, websites, and articles, which gave it a deep understanding of knowledge like language, common facts, and various domains of knowledge. This pre-trained knowledge is stored in the model's parameters, which has billions of values that represent how words and concepts are related. This is similar to how humans' long-term memory works, where facts and learned concepts are stored over time, even if we don't consciously access them every day. Let's talk about working memory, which is the context and in-context learning capability of the large language model. For example, imagine you have a conversation with the agent about planning a vacation. You might ask, I want to go on a vacation next month. I prefer somewhere warm, but I don't want to spend more than $2,000. Can you suggest some places? The agent processes this input and temporarily holding onto the key details like vacation, next month, warm place, and the budget of $2,000 in its working memory. So based on this, it may suggest places like Hawaii, Mexico, or the Caribbean that take into account the constraints that you provided. However, once this conversation moves to the next different topic, this specific information isn't retained permanently, just like how a human might forget these details once this discussion is over. Working memory, in the cases of the large language model, refers to this context window, the text input provided the agent in a conversation or tasks. This is temporary memory. Well, the agent keeps track of the relevant information for the current task or dialogue. The large language model uses this information to generate coherent responses or reasoning without permanently storing this data. This use of working memory is similar to how humans handle short-term information processing. For instance, if you are solving a math problem or holding on to a list of tasks mentally, your brain temporarily stores and manipulates that information and then discards it when it is no longer needed. Another mechanism is attention and reasoning. For example, let's say you ask the agent, based on my preferences, would you recommend Hawaii or Mexico for a vacation in February? So now the agent needs to reason over this information in its working memory to give you a meaningful answer. It might focus on key detail of weather on February, flight costs, and overall expenses. The agent can respond, Hawaii tends to be more expensive during February, especially flights, but Mexico offers warmer weather and more budget-friendly options, which might fit within your budget, $2,000. Here, the agent's attentional unit controls how it weighs different parts of the input, for example, the weather, the cost, and how it prioritizes that information when it's giving advice. So this mimics human reasoning. Well, we focus on certain aspects of a problem and ignore another which depend on the context. The reasoning process in a large language model is controlled by an attentional mechanism. In simple terms, the agent focuses on different parts of this information in its working memory to perform tasks like answering questions or make decisions. This is similar to how human focuses on different specific detail when we reason through a problem.